Hi and good morning. Uh, we will be going through chapter 2 and 3 today. Chapter 2 is basic chemistry. Most A&P classes kind of skip over basic chemistry. However, uh, that is what makes up our body, right? Is chemical reactions and how that goes. Let me get us back here to chapter 2. I accidentally clicked on chapter 1. Okay, chapter 2, basic chemistry. So, matter is the stuff of the earth. That is, it occupies anything that has space and mass. Matter may exist as one of three states. It could be a solid, it can be a liquid, or it can be a gas. Solid has a definite shape and a volume. This table would be a solid. A liquid would have a definite volume and the shape of a container. This glass of water would be a liquid. Gas is neither a definite shape nor a volume. Gas is a oxygen in the air that we breathe is a mixture of the gases. Uh, Matter can also be changed physically and chemically. Uh, Physical changes do not alter the basic nature of a substance, and examples of this is changes in the state of matter, solids, liquids, or gas. Chemical changes alters the chemical composition of a substance. Matter and energy. Energy is the ability to do work. It has no mass and does not take up space. Kinetic energy means the energy is being burned. Energy is doing work. Potential energy is stored or inactive energy. Uh, Forms of energy, we can have chemical energy, which is in charge of all cellular processes. And it's the chemical energy is stored in chemical bonds of substances. Electrical energy results from movement of charged particles, and mechanical energy is energy directly involved in moving matter. Radiant energy then travels in waves, and it's the energy of the electromagnetic spectrum. Energy from conversions. ATP traps the chemical energy for food in its bonds. So, what I want you to learn from this portion is I want you to know how matter and energy are interrelated. Uh, Matter is the substance of the living and the non-living objects, and energy is the movement of that substance. So, matter makes up all substances, and energy, ATP, traps that energy and then breaks it down. Then that energy breaks down, and that's what causes our movements. I also want you to understand the form of energy, what form of energy is used to transmit messages from one part of the body to the other. Uh, this is kinetic energy. Kinetic energy is anything that work is being done. What form of energy fuels cellular processes? The energy that fuels cellular processes is potential energy. What type of energy is available when we are still? This is potential energy. And when we're exercising, this is kinetic energy. What does it mean when we say that some energy is lost? every time energy changes from one form to another. It's never actually lost. Energy cannot be created and it cannot be destroyed. But the part that is given off is unusable. So if you put your finger really close to a light bulb that's been on for about an hour or so, you can see that it's emitting light, but some of that electrical energy reaching the bulb is actually creating heat, and that heat is unusable or lost. Okay, composition of matter. Elements are unique substances that cannot be broken down into simpler substances by ordinary chemical bonds. The fundamental units of matter, there's four basic elements. These are oxygen, carbon, hydrogen, and nitrogen. Oxygen is the very most common, and it's 65% of the body's mass. The periodic table contains a complete listing of all of these elements, and there's 118 of them. But the four most common is this oxygen, carbon, hydrogen, and nitrogen. The major role in oxygen is it's a major component of both organic and inorganic molecules as a gas. It's essential to the oxidation of glucose and other fuels during which cellular energy is produced. So without oxygen, we cannot produce that ATP, which creates energy in our body. Carbon is the primary element in all organic molecules. It includes carbohydrates, lipids, proteins, and nucleic acids. Hydrogen is a component of most organic molecules. It's an ion or a charged atom, and it influences the pH of body fluids. Nitrogen is a component of proteins and nucleic acids. It's a genetic material. But if you notice, oxygen is 65% of our body mass, whereas carbon is 18.5, hydrogen is 9.5, and nitrogen is 3.2. So we are a whole lot of oxygen. And that is partially because water is 80% of our body, and it is composed of hydrogen and 2 oxygens. Less than 3.9% of calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iodine, and iron are in our body, and less than 0.01% is chromium, cobalt, copper, fluorine, manganese, molybdenum, selenium, silicon, tin, and vanadium, and zinc. These are less than 0.01%. Atoms are the building blocks of elements. The atoms of elements differ from one to another. The atomic symbol is a chemical shorthand for each element. So the oxygen, the chemical shorthand is just O. Carbon, the chemical shorthand is just C. So that's the atomic symbol. If you're looking at table 2.1, you see all of the elements and then you see the atomic symbol next to it. Subatomic particles include the proton, the neutron, and the electrons. So atoms are indescribably small, but they're clusters of these subatomic particles, which is protons, neutrons, and electrons. AMU stands for atomic mass unit. So the proton is in the nucleus. It has an atomic mass unit of 1, and it has a positive charge. The neutron is again in the nucleus. It has an atomic mass unit of 1, and it has a 0 charge. It's a neutral charge. The electron orbits around the nucleus, and we're going to kind of look into that. We're going to learn how to draw these shapes or this orbit. But the electrons go in the outer rings of the nucleus. And we'll talk about it, but the first outer shell can hold 2. We'll go over that. All atoms are electrically neutral. The number of protons equals the number of electrons in an atom. So when we're drawing this model, we have to know that there's the same amount of protons and electrons. So the mass number is the number of protons plus electrons. The atomic number is just simply the number of protons. The atomic number, the number of protons, will indirectly tell us how many electrons are there, because you have the same number of protons and electrons. So, for instance, calcium has 20 protons, so it also has 20 electrons. A positive and a negative charge cancel each other out. Ions are atoms that have been lost or gained electrons. The planetary model. This is what I'm going to teach you how to draw. The planetary model, where did that go? I wanted to read you this one thing. The planetary model is not the most accurate at the current moment. It's kind of being viewed as old school. Where did I see that in here? Oh, here it is. Okay. The planetary model of an atom portrays the atom as a miniature solar system in which the protons and the neutrons are clustered at the center of the atom in the atomic nucleus. Because the nucleus contains all the heavy particles, it's fantastically dense and positively charged. The tiny electrons orbit around the nucleus in a fixed, generally circular orbit, like planets around the sun. But we can never determine the exact location of the electrons in that at a particular time because they jump around following unknown paths. So instead of speaking of specific orbits, chemists talk about orbitals, which are regions around the nucleus in which the electrons are likely to be found. The orbital model depicts the general location of the electrons outside the nucleus as a haze of negative charge, referring to the electron cloud. Regions where electrons are most likely to be found are shown by denser shadows rather than orbiting lines. Though it's now considered outdated, the planetary model is simple and it's easy to understand and use. And that's the reason why we're teaching that in this class, is because the planetary model is very easy to learn from, whereas this orbital model uh, is uh, more accurate, but it's more difficult to learn. So we're going to learn to draw a planetary model. Let me go ahead and okay, so I got to stop the share process, stop that. And then I'm going to open a whiteboard. Okay, now you guys can all see my whiteboard. So what we're going to do here is we're going to turn to page 30. Okay, and we're gonna draw a calcium. So uh, all right, so uh there's the little calcium ion. Now, that's the nucleus. Okay. Now we're gonna draw the valence shells. The valence shells um are the only electrons that are important in the bonding behavior. They're the atoms in the outermost shell. It's the electrons that are in the outermost shell. So we see that calcium has 20 proteins. This means that it also has 20 electrons. So the first valence shell can hold 2 electrons. Okay, so we've got these 2 little electrons. We still have 18 left. So the second valence shell can hold 6. Okay, so now we've got 6. 8. I'm sorry. The second valence shell can hold 8. So now we've got 10, uh, but calcium has 20. So this is going to be our last valence shell. And the last valence shell can hold 17. Can accommodate 17. So we've got 2, 4, 6, 8, 10. There is only 10 left. So 2, 4, 6, 8, 10. These, so in calcium, there is 10 electrons in the valence shell. All right. And so that is how you draw the planetary model of an atom. There we go. And then let's come back to our screen share. All right. So the planetary model, which is what we just drew, portrays the atom as a miniature solar system. The protons and neutrons are in the atomic nucleus, and the electrons are in the orbitals around the nucleus. Oh, I guess I could have drawn a helium atom, but a helium atom, you have the nucleus, you have two protons, which means you have two electrons. So since the inside shell can support two, the helium atom has two in its valence shell. The orbital model, electrons are depicted by an electrical cloud, a haze of negative charge around the outside of the nucleus. The electrons determine an atom's chemical behavior and bonding properties. Although outdated, the planetary model is simple and easy to use and understand. Okay, before we go into identifying elements. Oh, no. Okay, to identify an element, we're going to need to know the atomic number. And if we turn to number 1 in our assignment, number 1 is which of the following are true concerning the atomic nucleus? It contains the mass of the atom. The negatively charged subatomic particles are here. The subatomic particles can be ejected, or it contains subatomic particles that determine the atomic number. So as we read through these next few things, think about that. And then we'll go into number 2, which is pick out the correct matches of the element and number of valence electrons, and then draw the planetary models of each atom to help you choose the best answer. Okay, so the atomic number is equal to the number of protons that the atom contains. It's unique to atoms of a particular element, and it indirectly tells the number of electrons in an atom. We've discussed that just a little bit. The atomic mass number is the sum of the protons and neutrons contained in an atom's nucleus. The atomic weight is approximately equal to the mass number of the element's most abundant isotope. And the isotopes will be discussed in just a second. Okay, so which of the following is true concerning, flip over here so you can see it. Which of the following is true concerning the atomic nucleus? It contains the mass of the atom. For sure, it contains the mass of the atom. The mass number of any atom is the sum of the masses of all the protons and neutrons contained in the nucleus. The negatively charged subatomic particles are here. That is not correct. The subatomic particles can be ejected. Absolutely. Subatomic particles are protons, neutrons, and electrons. And isotopes, which again, we're going to talk about in just a minute, vary in the number of neutrons they contain. The heavier isotopes are unstable and they tend to release energy in order to become more stable. Heavier isotopes are called radiositopes. The glue that holds the atomic nuclei together is weaker in the heavier isotopes, and this is what causes the spontaneous uh, atomic decay that's called radioactivity. All types of radioactive decay involve the ejection of particles or electromagnetic energy from the atom's nucleus and is damaging the living cells. It's damaging to the living cells. So, yes, subatomic particles can be ejected. And we're going to talk about the isotopes in just a second. It contains subatomic particles that determine the atomic number. If you remember, the atomic number is equal to the number of protons its atom contains. So, yes, the protons are located in the nucleus, and therefore, the nucleus does contain the subatomic particles that determine the atomic number. It contains subatomic particles that interact with other atoms. That is not correct. All right. We've already talked about these just a little bit. Isotopes are atoms that have the same number of protons and electrons, but they vary in the number of neutrons. Isotopes have the same atomic number, but different masses. Atomic weights and isotopes. Radioisotopes are heavy isotopes of certain atoms, and they tend to be unstable. They decompose to more stable isotopes by way of radioactivity. Radioactivity is the process of spontaneous atomic decay, and it's used to tag and trace biological molecules through the body. A molecule, two or more atoms of the same element combined chemically. Example of a chemical reaction shown as a chemical equation resulting in a molecule. A hydrogen atom chemically bonded with another hydrogen atom creates a hydrogen molecule. The reactants are the atoms on the left, and the product is the molecule on the right, presented in a molecular formula. A compound is two or more atoms of a different element combined chemically to form a molecule of a compound. Examples of a chemical reaction resulting in a compound. 4 hydrogen plus 1 carbon equals carbon, and 4 hydrogen. This is what methane is. Now notice there is the same number of hydrogen here as there is here, same number of carbon as there is here and here. It just all combines and creates methane. Okay. Chemical reactions occur when the atoms combine with or dissociate from other atoms. Chemical bonds are energy relationships involving interactions among the electrons of the reacting atoms. The role of electrons. The role of electrons. Electrons occupy energy levels called electron shells or energy levels. Electrons closest to the nucleus are most strongly attracted to its positive charge. Distant electrons further from the nucleus are likely to interact with other atoms. Each electron shell has a distinct property. How to fill the electron shells. We just went over this. I drew you a little diagram. The shell 1 can hold a maximum of 2 electrons. So again, if you're looking at table 2.3, we'll go with carbon now, okay? So carbon has 17 protons, which means that it has also 17 electrons. If you look over on the far right, it says there's 7 electrons in the valence shell. That is because, oh, sorry, carbon is, I went off the wrong line. Carbon has 6 protons, which means, and 4 of those are in the electron valence shell. That is because in the first valence shell, there's 2 electrons. The second valence shell can hold 8, but carbon only has 4. So there's 4 electrons in the valence shell. The valence shell is the outermost shell. So shell 1 has 2. Shell 2 becomes the valence shell and has 4. Bonding involves interactions only between the electrons in the valence shell, the outermost shell. Those are the only electrons that associate with any other atom. Atoms with a full valence shell do not form bonds. So the outermost energy level, the valence shell, is complete in helium and in neon. So they don't interact with other cells. The rule of 8, the key to chemical reactivity is referred to as the rule of 8. In the absence of a full valence shell, atoms interact in such a way that they will have 8 electrons in their valence shell. The first electron shell represents an exception to this rule because it is full when it has 2 electrons. When the valence shell of an atom contains 8 electrons, the atom is completely stable and is chemically inactive. When the valence shell contains fewer than 8 electrons, an atom will tend to gain, lose, or share electrons with other atoms to reach a stable state. When any of these events occur, chemical bonds are formed. Okay, so if we go to our assignment and go to number 2, it says pick out the correct matches of elements and number of valence electrons, drawing planetary models of each atom to help you choose the best answer. Okay, oxygen. We know oxygen has 8 protons, and therefore we know it also has 8 electrons. Okay, so in the outer shell, the valence shell, we're going to, first shell has 2. So the outer shell has to have 6. So we know that that one is correct. Chlorine. Chlorine has an atomic number, total protons of 17. So there's 17 electrons. Shell 1 can accommodate 2. Shell 2 can hold up to a maximum of 8. Shell 3 can accommodate 17. So the valence shell of chlorine is 7. So this one is not correct. Phosphorus. Phosphorus has an atomic number of 15. So there's 15 electrons. Shell 1 can accommodate 2, shell 2 can accommodate 8, and shell 3 can accommodate 17, but there's only 5 left. So the valence shell of phosphorus has 5. Nitrogen has the atomic number of 7, which indirectly tells us that there's 7 electrons in nitrogen. Shell 1 can accommodate 2, shell 2 can accommodate 8. However, there's only 5 left. So the valence shell of nitrogen is 5. Okay, carbon. Uh, Carbon, let's see. Carbon has an atomic number of 6, so it has 6 electrons. Shell number 1 can hold 2, which leaves 4 left. The valence electron is the electrons in the valence shell, so carbon has 4. This is correct. Let's go back over to here. All right. Atoms will gain, lose, or share electrons to complete their outermost orbitals when fewer than 8 electrons are in that valence shell. Chemical bonding will help atoms achieve a stable valence shell, and that's the goal there is stability. Ionic bonds form when electrons are completely transferred from one atom to another. Ionic bonds allow atoms to achieve stability through the transfer of electrons. Ions result from the result of a gain or a loss of electrons. Anions have a negative charge due to a gain of electrons, and cations have a positive charge due to a loss of electrons. They tend to stay close together because opposite charges attract. See, so sodium has 11 electrons. So 2 in the innermost shell, 8 in the outermost shell. That's 8, 9, 10. So it has only 1 in its valence shell. So chlorine, if we remember, chlorine has 7 in its outermost shell. So sodium and chlorine mix. Okay, so that one little electron fits into that space, giving this a stable outside shell, and it becomes sodium chloride. Covalent bonds are where atoms become stable through shared electrons. Electrons are shared in pairs. Single covalent bonds share 1 pair of electrons. Double covalent bonds share 2 pairs of electrons. Covalent bonds can be described as either nonpolar or polar. Nonpolar covalent bonds are where electrons are shared equally between the atoms of the molecule. Electrically neutral as a molecule, an example of this would be carbon dioxide. Covalent bonds can be described as either polar or nonpolar. Polar covalent bonds are electrons are not shared equally between the atoms of the molecule. Molecule has a positive and a negative side or pole. An example of this would be water. Hydrogen bonds are extremely weak chemical bonds, and they're formed when a hydrogen atom is attracted to the negative portion, such as um, an oxygen or a nitrogen atom of a polar molecule. It's responsible for surface tension of water, and it's important for forming intramolecular bonds, as in protein structures. Make sure we haven't missed anything real fast. We have not just yet. Okay, patterns of chemical reactions. A synthesis reaction occurs when two or more atoms or molecules combine to form a larger, more complex molecule, which can be represented as A plus B creates AB. Atoms or molecules combine to form larger or more complex molecules. Energy is absorbed for bond formation and underlies all anabolic building activities in the body. Decomposition reaction is where it breaks it down. The water for the solvent for this is water, and we'll go over that in just a second. But decomposition reaction, molecule is broken down into smaller molecules. Chemical energy is released. It underlies all catabolic destructive activities in the body. Smaller particles are bonded together to form larger, more complex molecules. An example of this is amino acids are joined together to form a protein molecule. Bunch of amino acids form together to make a protein. Decomposition is where glycogen is broken down to release the glucose units. So glycogen is released. Our body breaks it down to create glucose molecules. An exchange reaction is where you have AB plus C, and it breaks down to create AC plus B. It involves simultaneous synthesis and decomposition reaction as bonds are both made and broken. The switch is made between molecule parts and different molecules are made. Bonds are both made and broken in our bodies. ATP transfers its terminal phosphate group to glucose to form glucose phosphate. Most chemical reactions are reversible. Reversibility is indicated by a double arrow. When arrows differ in length, the longer arrow indicates the more rapid reaction or major direction of progress. Factors influencing the rate of chemical reactions are shown in 2.4. Factors that increase the rate of chemical reactions are temperature, concentration of reacting particles, the size of the particle, and the presence of a catalyst. Inorganic compounds lack carbon, and they tend to be small, simple molecules. These include water, salts, and many but not all acids and bases. Organic compounds contain carbon. They are very large covalent molecules, and they include carbohydrates, lipids, proteins, and nucleic acids. Water is the most abundant inorganic compound in the body. It accounts for 2/3 of the body weight, and its vital properties include heat capacity, polarity, solvent properties, chemical reactivity, and cushioning. So if you come over here to our assignment, you'll see important functions of water include which of the following. It does definitely provide cushioning. It provides cushioning in the cerebrospinal fluid. That's the spinal fluid forms a cushion around the brain that helps to protect it from physical trauma, and that's made up of a lot of water. It does act as a transport medium because nutrients, respiratory gases, which is oxygen and carbon dioxide, and waste can dissolve in water. It can act as a transport and exchange medium in the body. It participates in chemical reactions. Uh, Water is an important reactant in some types of chemical reactions, for example, to digest food or break down biological molecules. Water molecules are added to the bonds of the larger molecules in order to break them down. It absolutely acts as a solvent for sugar, salt, and other solutes. Water is an excellent solvent because of its polarity. Indeed, it's often called the universal solvent. It reduces temperature fluctuations. Water has a high heat capacity. It absorbs and releases large amounts of heat before its temperature changes. Okay, and also number 4 is right here as well. If you turn to page 41, we're going to discuss the pH balance and alkaline and acidic. So solutions with a pH lower than 7 are acidic, and higher than 7 is considered alkaline. So if you look on page 41, it has a list of different items and what their pH balance is. So gastric juice has a pH of 2. So pH of 2 makes it acidic. So this is not alkaline, it's acidic. Water is always neutral. Water sits right directly at a pH of 7. Blood sits at a pH of 7.4 ideally. And so blood is technically acidic. Lemon juice has a pH of 2, so it is acidic. Oh, I meant to say blood is alkaline because it's 7.4. Lemon juice has a pH of 2, and so it is acidic. And ammonia has a pH of 10.5 to 11.5, so it is absolutely alkaline. So the 2 in this list that are alkaline is blood and ammonia. All right, let's go back to this. I already did that. Inorganic compounds, polarity or solvent properties. Water is often called the universal solvent. Solvents are liquids or gases that dissolve in smaller amounts of solutes. Solutes are solids, liquids, or gases that are dissolved or suspended by solvents. Solution forms when solutes are very tiny. Colloid forms when solutes of intermediate size form translucent mixtures. Chemical reactivity. Water is an important reaction in some chemical reactions. Reactions that require water are known as hydrolysis reactions. An example of this is water helps to digest food or break down biological molecules. Water helps with cushioning. It serves as a protective function. Examples are cerebrospinal fluid, which protects the brain from physical trauma, and amniotic fluid, which protects the developing fetus. Salts are ionic compounds, and they contain cations other than hydrogen and anions other than OH. They easily disassociate or break apart into ions in the presence of water. Salts are vital to many body functions. Sodium, potassium ions are essential for nerve impulses and also for our heart to beat. All salts are electrolytes, and electrolytes are ions that conduct electrical currents. Acids, electrolytes that dissociate or ionize in water, release hydrogen ions. Protons, hydrogen, are hydrogen donors. Examples, hydrogen chloride breaks down to be hydrogen and chloride. Strong acids ionize completely and liberate all their protons. Weak acids ionize completely. Inorganic compounds, bases, electrolytes that dissociate in water and release hydro ions. Proton acceptors, an example, sodium hydroxyl breaks down to become sodium and hydroxyl. Neutralization reaction, a type of exchange reaction in which acids and bases react to form water and salt. pH measures the relative concentration of hydrogen ions in most body fluids. pH scale is based on the number of protons in a solution. The pH scale runs from 0 to 14. Each excessive change of 1 pH unit represents a 10-fold change of hydrogen concentration. So if you're at 1, you have 10 hydrogens. If you have a pH of 2, 20. pH of 3, oh. So it increases by 10% each time, a 10-fold change. A neutral pH is 7. Neutral means the number of hydrogen ions is exactly equal to the number of hydroxyl ions. Acidic solutions have a pH below 7. And so it has more hydrogen than hydroxyl. Basic solutions have a pH of above 7, so it has fewer hydrogens than hydroxyl. Buffers are chemicals that can regulate pH. Okay, we went over this. Gastric juices have 2. Water has 7. Blood has 7.4. Lemon juice has a pH of 8. No, that's not true. Lemon juice has a pH of 2. Ammonia has a pH of 10.5. All right. Organic compounds. Most organic compounds are very large molecules, but their interactions with other molecules typically involve only small reactive parts of their structure called functional groups. Many organic compounds, carbohydrates and proteins, for example, are polymers. Polymers are chain-like molecules made of similar or repeating units, monomers. Many biological molecules are polymers, such as carbohydrates and proteins. Dehydration synthesis. During dehydration, the monomers are, these monomers, they are held together by dehydration synthesis and create polymers. Hydrogen ion is removed from one monomer, while a hydroxyl group is removed from the other monomer it is to be joined with. Water is removed at the site where the monomers join, which is the dehydration. When polymers must be broken down or digested to their monomers, the reverse process, so dehydration synthesis is growing at, the reverse process is called hydrolysis. As a water molecule is added to each bond, the bond is broken and the monomer is released. Carbohydrates contain carbon, hydrogen, and oxygen. This includes sugars and starches. They're classified according to size and solubility in water. Monosaccharides are simple sugars and the structural units of carbohydrate groups. Disaccharides are two, hence the word di, are two simple sugars joined by dehydration synthesis. So it's joined by dehydration synthesis. Polysaccharides are long branching chains of linked simple sugars. Monosaccharides are simple sugars. They're single chain or single ring structures. They contain 3 to 7 carbon atoms. Examples of monosaccharides are glucose, which is blood sugar, fructose, galactose, ribose, and deoxyribose. Disaccharides are two simple sugars joined by dehydration synthesis. Examples include sucrose, lactose, and maltose, too large to pass through the cell membrane. Dehydration. Polysaccharides are long branching chains of linked simple sugars, large insoluble molecules. They function as storage products, and an example includes starch and glycogen. Lipids are like carbohydrates. All lipids contain carbon, hydrogen, and oxygen atoms, but in lipids, carbon and hydrogen atoms far outnumber the oxygen atoms. They are insoluble in water, but they are soluble in other lipids, such as alcohol or acetone. These are the lipids that are found in the body. Triglycerides or neutral fats are found in fat deposits. They're the source of stored energy, and they're composed of two types of building blocks, fatty acids and one glycerol molecule, saturated fatty acids or unsaturated fatty acids. Saturated fat at room temperature, the molecules of the saturated fat, such as this butter, are packed closely together, forming a solid. When they're warm, they break down. Fatty acid chains of triglycerides Glycerides, saturated fats contain only single covalent bonds and chains are straight. They exist as solids at room temperature and since molecules are packed so closely together. Unsaturated fats contain one or more double covalent bonds, causing chains to kink. They exist as liquid oils at room temperature. They're considered heart healthy. Trans fat is oils that have been solidified by the addition of hydrogen atoms and double bond sites. They increase the risk of heart disease. Omega-3 fatty acids are found in cold water fish and plant sources, and they include flax, pumpkin, and chia seeds, walnut, and soy foods. They appear to decrease the risk of heart disease. Phospholipids. The presence of phospholipids in cell membranes allows the cells to be selective about what may enter or leave. So you do need to understand that. But they contain two fatty acid chains rather than three, and they are hydrophobic, so they don't go well with water. Phosphorus containing polar head carries an electrical charge and is hydrophilic, which means water loving. Charged head region interacts with water and ions, while the fatty acid chains tails do not, and they form membranes. All right, steroids, formed of four interlocking rings. They include cholesterol, bile salts, vitamin D, and some hormones. Some cholesterol is ingested in animal products. The liver also makes cholesterol. Cholesterol is the basis for all steroids made in the body. All right, so let's go. Oh, sorry. Proteins account for over half of the body's organic matter, and it provides for construction materials for body tissues. It plays a vital role in cell function and acts as enzymes, hormones, and antibodies. It contains carbon, oxygen, hydrogen, nitrogen, and sometimes sulfur, and it's built from amino acids. Okay. So the building blocks of proteins are small molecules called amino acids. There is 20 varieties of amino acids, and they're all found in human proteins. All amino acids have an amine group, which gives them the basic properties, and an acid group, which allows them to act as acids. In fact, all amino acids are identical except for a single group of atoms called the R group. The difference in the R group makes each amino acid chemically unique. For example, an extra acid group in the R group, such as aspartic acid, makes the amino acid more acidic, and sulfuride in the R group is often involved with stabilizing protein structure by binding to another amino acid with the same person. Polypeptides contain fewer than 50 amino acids. Large protein structures contain more than 50 acids. Large complex proteins contain 50 to thousands of amino acids, and the sequence of amino acids produce a variety of proteins. The structural level of a protein, the primary structure is a strand of amino acid as beads. The secondary structure is chains of amino acids with a twist or a bend. An alpha helix resembles a metal spring. Beta is a pleated sheet, resembles the pleats of a skirt or sheets of paper folded together. If you're looking at page 48, 49, and 50, it will map you through this. The tertiary structure is a compact ball-like or globular structure, and that is the quaternary structure is a result of a combination of two or more polypeptide chains. There we go, and see all of the pictures. Based on their overall shape and structure, proteins can be classed as either fibrous or globular. So fibrous proteins are also called structural proteins, and they appear most often in the body structures. Some exhibit only secondary structure, but most have tertiary or even quaternary structures. Globular, they appear in body structures. They exhibit secondary, they bind structures together and exist in body tissues. They are stable proteins, and this is collagen and keratin are the two that it. Globular proteins are mobile and generally compact. They're spherical molecules that have at least tertiary structure. These water-soluble proteins play crucial roles in virtually all biological processes. Enzymes. Enzymes are functional proteins that act as biological catalysts. They increase the rate of chemical reaction and they bind to substrate at an active site to catalyze reactions. They can be recognized by their ASE suffix. Hydrolase is an enzyme. Oxidase is an enzyme. All right, let's go back and get the questions that we've passed on our assignment. So, number 5, what type of lipid is stored in fat deposits beneath the skin? This is vitamin D. If we turn to page 47, they're on table 2.5. It shows each lipid type, which vitamin D is a type of lipid, and its location and its function. So vitamin D is a fat-soluble vitamin that is produced in the skin on exposure to UV radiation, and it's necessary for normal bone growth and function. Number 6, factors that increase the speed of chemical reactions include can't remember what page this is on. It's increase the temperature, increase the particle size, and increase the concentration of the reactants, and catalysts. A catalyst is a substance that increases the rate of the chemical reaction without becoming part of the product itself. But Well, that's okay. So it increases the temperature, increase in the particle size will uh increase the speed, increasing the concentration of the reactions will increase. Oh, it's on page 38. Factors influencing the rate of chemical reactions. Several factors, including temperature, concentration of particles, and size of particles, influence the kinetic energy and hence the speed of the particles and the force of the collisions. Which of the following? Oh, we have not made it to this one just yet. So let's come back to here. Nucleic acids. The role of a nucleic acid is fundamental. They make up your genes, which provide the basic blueprint for life. They not only determine what type of organism you'll be, but also directed your growth and your development. And they did this largely by dictating protein structures. So they form genes. They're composed of carbon, oxygen, hydrogen, nitrogen, and phosphorus. They're the largest biological molecules in the body. Two major kinds are DNA and RNA. Nucleic acids are built from building blocks called nucleotides. Nucleotides contain three parts. The nitrogenous base, which can be classified by adenine, guanine, cytosine, thymine, and uracil. Pentose, which is a 5-carbon sugar, and a phosphate group. DNA, the genetic material found within the cell's nucleus, provides instructions for every protein in the body. It's organized by complementary bases to form a double-stranded helix. It contains the sugar deoxyribose and the bases adenine, thymine, cytosine, and guanine. It replicates before cell division. RNA carries out exactly what DNA tells it to. It's created from a template of DNA. It contains the sugar ribose and the bases adenine, uracil, cytosine, and guanine. The three varieties are messenger, transfer, and ribosomal RNA. Adenosine triphosphate, this is the energy of our body. It's all important because it provides a form of chemical energy that all body cells can use. Without ATPs, molecules cannot be made or broken down, and cells cannot maintain their membrane boundaries, and all life processes grind to a halt. ADP, thank you. ADP accumulates as ATP is used for energy. ATP is replenished by oxidation of food and fuels. 3 examples of how ATP drives cellular work are shown next. All right. We will now move on to chapter 3, cells and tissues. I understand this is kind of a long one. Cells and tissues. Cells are the structural units of all living things, and the human body has 50 to 100 trillion cells. Cell theory has 4 basic rules, okay? So a cell is the basic structure and functional unit of all living organisms. That's the first rule of cell theory. The activity of an organism depends on the collective activities of its cells. According to the principle of complementary, the activities of the cells are dictated by their anatomy, and their anatomy is what determines their function. And continuity of life has a cellular basis. So everything in life, if you damage your cells, then you damage your body. Most cells are composed of 4 elements: carbon, hydrogen, oxygen, and nitrogen. And they are made up of 60% water. In general, a cell has 3 major parts: the nucleus, the cytoplasm, and the plasma membrane. The nucleus, the cytoplasm, and the cell membrane. The nucleus is the control center of the cell. It contains genetic material known as deoxyribonucleic acid, which we call DNA. DNA is needed for building proteins, and it's necessary for cell reproduction. That is the blueprint of what we are. There's 3 regions within the nucleus: the nuclear envelope, which is the membrane, the nucleus, and the chromatin. So the chromatin, or the nucleus, the chromatin, and the nuclear envelope. The nuclear envelope consists of a double membrane that bounds the nucleus. It contains the nuclear pores that allow for exchange of material with the rest of the cell. So this is it's semi-permeable. It allows some things in and keeps some things out. It encloses the jelly-like fluid that's called the nucleoplasm. The nucleus, the nucleus contains 1 or more dark staining nuclei, which are the sites of ribosome assembly. Ribosomes migrate into the cytoplasm through nuclear pores to serve as the site of protein synthesis. The chromatin, composed of DNA wound around histones, proteins. The chromatin is scattered throughout the nucleus and present when the cell is not dividing. It condenses to form dense rod-like bodies called chromosomes when the cell divides. The plasma membrane is a transparent barrier for cell contents. It contains cell contents, and it separates the cell contents from the surrounding environment. The fluid mosaic model is constructed of 2 layers of phospholipids arranged tail to tail. Cholesterol and proteins scattered among the phospholipids. Sugar groups may be attached to the phospholipids, forming glycolipids. Okay, so I want you to look at this little structure right here. The phospholipids are polar molecules. The charged ends interact with water, and the fatty acid chains do not. It is this property of polarity that makes the phospholipids a good foundation for cell membrane. So that is the reason why it is flexible. It can move. They call it a mosaic. Phospholipids arrangement in the plasma membrane. Hydrophilic is water-loving. Polar heads are oriented on the inner and outer surface of the membrane. Hydrophobic or water-fearing non-polar tails form the center or interior of the membrane. This interior makes the plasma membrane relatively impermeable to most water soluble molecules. The role of proteins in the plasma membrane is it's responsible for specialized membrane functions such as enzymes, receptors for hormones or other chemical messengers, and transports as channels or carriers. The role of sugars, glycoproteins are branch sugars that are attached to proteins that abut the extracellular space. Glycocalyx is the fuzzy, sticky, sugar-rich area in the cell's surface. Kind of think of it like it's sugar-coated. And the purpose of that is because those glycocalyx, the fuzziness, will act as receptors. They'll attract certain bacterias and viruses so that it binds to that and then plays a role in cell-to-cell recognition and interactions. It also tells us what your blood type is. The cell membranes are bound together in glycoproteins in the glycocalyx. So it also causes cell junctions. There is 3 different types of cell junctions. There is the tight junctions, desmosomes, and gap junctions. Tight junctions are adjacent plasma membranes. They fuse together tightly like a zipper to prevent substances from passing through the extracellular space between the cells. This prevents digestive enzymes from seeping into the bloodstream. Desmosomes prevent cells subjected to mechanical stress, such as the heart muscle and the skin cells, from being pulled apart. Structurally, these junctions are button-like thickening of adjacent plasma membranes that are connected by fine protein filaments. Gap junctions function mainly to allow communication. These junctions are commonly found in the heart between the embryonics and in between the embryonic cells. In gap junctions, the neighboring cells are connected by hollow cylinders composed of proteins called connexons that span the entire width of the abutting membranes. Okay, so here we view the cell, we can see all the cell junctions. Okay, we've got a tight junction, the desmosomes, and the gap junction. Okay. This also illustrates the microvilli, which is these up here. And that increases the cell's surface area for absorption. So I want to come back to our assignment. Which of the following would you expect to find in cells, in or on cells whose main function is absorption? It is microvilli. Okay. Gap junctions are found on cells whose main function is communication. And the secretory vesicles are protein sacs that are tagged for export in the Golgi apparatus. And the villi are uh, finger-like motions in usually in your intestines, or are in your intestines, that will help move food. But the microvilli, uh, those are on the cell and they increase the surface area for absorption. Okay. And then also, oh, we already answered this one. Um, Adult cell types, you might expect to have gap junctions. So, gap junctions allow for communication. So, skeletal muscle really doesn't have a need for communication with each other. Uh, Bone doesn't have a need for communication. Heart muscle absolutely does. Uh, and so in heart muscle, the gap junctions and the neighboring cells are connected by hollow cylinders, which are composed of proteins that span the entire width of the budding membranes. This is why our heart is an electrical pump, and when the SA node, the node that fires the first electrical activity of each heartbeat, when it fires, it reacts as like a wave throughout the atria of the heart. The reason that electrical activity is allowed to act like a wave is because of this gap junction. So adult cell types you might expect to have gap junctions will be the heart muscle. And that's what it allows it to communicate like a wave, is because those hollow cylinders the cells are all connected. Hmm. All right. I don't believe. Nope, we haven't. Okay. So the cytoplasm. The cytoplasm is the cellular material outside of the nucleus and inside the plasma membrane. It's the site of most cellular activities, and it has three major components. It's got the cytosol, the inclusions, and the organelles. The cytosol is the semi-transparent fluid that suspends other elements. It's dissolved in cytosol, dissolved in the cytosol, dissolved in the cytosol is water and nutrients and a variety of other solutes. Inclusions are chemical substances such as stored nutrients or cell products, and they float in the cytosol. And then the organelles, those are like tiny organs within the cell, and they're metabolic machinery of the cell that perform functions for the cell. There are a lot of them. We're going to go through all of them. There's the mitochondria, the ribosomes, the endoplasmic reticulum, which we call ER, and there's smooth ER, and then there's rough ER. The rough ER has ribosomes on it. And then there's the Golgi apparatus, the lysosomes, and the peroxisomes. Okay, here is a picture. These are all the organelles within the cell. The mitochondria is the powerhouse of all the cells. The mitochondrial wall consists of a double membrane with cristae or crests. on their inner membrane, and they carry out reactions in which oxygen is used to break down food into ATP. That's why it's called the powerhouse, is because the mitochondria supply most of this ATP. So cells that are very busy have hundreds of mitochondria. Uh, which replicate themselves by pinching in half. Ribosomes are made of protein and ribosomal RNA. They're the sites for protein synthesis in a cell, and they're found at two locations. You can find them just floating free in the cytoplasm, or you can find them as part of the rough endoplasmic reticulum. The presence of the ribosome is what makes that endoplasmic reticulum the rough endoplasmic reticulum. Without the ribosomes, it's called smooth endoplasmic reticulum. Endoplasmic reticulum is fluid-filled tunnels or canal that carries substances within the cell. It's continuous with the nuclear membrane. The two types are rough ER and smooth ER. Rough ER is studded with ribosomes. These ribosomes synthesize proteins, and the endoplasmic reticulum transports vesicles and moves proteins within the cell, abundant in cells that make and export proteins. The smooth ER lacks ribosomes and functions in lipid metabolism, and the detoxification of drugs and pesticides. The Golgi apparatus. Oh, so if we come to number 11, a cell stimulated to increase its steroid production will have an abundance of smooth ER. Smooth ER plays a role in lipid metabolism. Lipid metabolism is the breakdown of cholesterol and fat. And smooth ER also plays a role in detoxification of drugs and pesticides. Body cells that produce steroid-based hormones are chock full of smooth ER. The Golgi apparatus. The Golgi apparatus appears as a stack of flattened membranes associated with tiny vesicles. It modifies and packages proteins arriving from the rough ER via transport vesicles. It produces different types of packages, secretory vesicles, which is pathway 1, in-house proteins and lipids, which is pathway 2, or lysosomes, which is pathway 3. Lysosomes are membranous bags containing powerful digestive enzymes. These enzymes can digest worn out or non-soluble cell structures. They house phagocytes that dispose of bacteria and cell disease. Peroxisomes are membranous sacs that contain powerful oxidase. This oxidase is an enzyme that is used in molecular oxygen to detoxify a number of harmful or poisonous substances, including alcohol and formaldehyde. Its most important function, however, is to disarm disarm dangerous free radicals. So let's go back to here. Go number 10. A cell with abundant peroxisomes would most likely be involved with secretion. Nope, we already know it's detoxification, right? All membranous sacs containing powerful oxidase, enzymes that use molecular oxygen um, to detoxify a number of harmful or poisonous substances. So it's detoxification activities. The cytoskeleton is a network of protein structures that extend throughout the cytoplasm. It provides the cell with an internal framework that determines the cell shape, supports the organelles, and provides the machinery for intracellular transport. There is 3 different types of elements from the cytoskeleton: the microfilaments, the intermediate filaments, and the microtubulars. The centrosomes are rod-shaped bodies that are made of 9 triplets of microtubules. They generate microtubules and they direct the formation of mitotic spindle during cell division. Cell extensions, surface tension found in some cells. Cilia move materials across the cell surface located in the respiratory system to move mucus. Flagella propel the cell. The only flagellated cell in the human body is sperm. The microvilli are tiny finger-like extensions of the plasma membrane, and again, they increase the surface area for absorption. The human body houses over 200 different cell types, and they all vary in size and shape and function. Like our human body, the anatomy is the structure, the physiology is the function of the cell. Cells can vary in length of 1/12,000th of an inch to over 1 yard in our nervous system. And the cell shape reflects its specialized function. Cells that connect body parts. There is the fibroblast. Let me come over to here because this part I know does have a fibroblast. This cell has an elongated shape and cable-like fibers that secrete. It has abundant rough ER and a large Golgi apparatus to make and secrete protein building blocks. Erythrocyte carries oxygen in the bloodstream. Cells that cover and line the body organs are the epithelial cells. They pack together in sheets, and their intermediate fibers resist tearing during rubbing or pulling. Cell diversity, cells that move organs and body parts. The skeletal muscle and smooth muscle cells. Contractile filaments allow cells to shorten forcibly. A cell that stores nutrients is fat cells. cells that fight disease are white blood cells, and they digest infectious microorganisms. Cells that gather information and controls the body are nerve cells. Reproductive cells are oocytes, large cells in the body, and divides to become an embryo upon fertilization, or the sperm, built for swimming and to the egg for fertilization. Flagellum acts as the motile whip, so that's the sperm's tail. Cells have the ability, all cells have the ability to metabolize, digest food, dispose of waste, reproduce, grow, move, and respond to a stimulus. Homogeneous mixture of two or more components, solvent and solute. A solvent, dissolving medium present in the larger quantity. The main solvent in our body is water. Solutes are components in smaller quantities within a solution, like salts. Intracellular fluid is the nucleoplasm and cytosol. Solution containing gases, nutrients, and salts are dissolved in water. Extracellular fluid is the fluid on the exterior cell. It contains thousands of ingredients such as nutrients, hormones, neurotransmitters, salts, waste products. The plasma membrane is a selectively permeable barrier. Some materials can pass through while others are excluded. For example, nutrients can enter the cell. Undesirable substances are kept out. There are two basic methods of transport. There is passive and active. Passive is where substances are transported across the membrane without any input from the cell. And active is where the cells provide a metabolic energy. It takes energy to drive that transport process. Diffusion. Molecule movement is from high concentration to low concentration down a concentration gradient. A concentration gradient is a concentration gradient is where it goes from a low concentration to a higher concentration. Particles tend to disrupt themselves evenly within a solution. Kinetic energy causes the molecules to move about randomly, and the size of the molecule and temperature affect the speed of diffusion. Okay, so let's come over to our number 12. For diffusion to occur, we definitely need a selectively permeable membrane. That's what allows the barrier so that some substances can pass through while excluding others. If we had equal amounts of solute, nothing would happen. So that's not correct. So a selective permeable membrane, not equal amounts of solute. Concentration difference is necessary because the greater the difference, the faster the currents occurs. And then we don't really need a carrier system for all diffusion. We do for active, but not for passive. All right. Membrane transport. Molecules will move by diffusion if any of the following apply. Molecules are small enough to pass through the membrane's pores or the semi-permeable membrane. The molecules are lipid soluble. Molecules are assisted by a membrane carrier. Types of diffusion, there's simple diffusion, which is an unassisted process. It just happens. Solutes are lipid soluble and small enough to pass through the membrane. That's in a simple diffusion. In osmosis, the simple diffusion of water across a selectively permeable membrane can be highly polar molecules easily cross the plasma membrane through aquaporins. Water moves down its concentration gradient. Osmosis, isotonic solution have the same solute water concentration as cells and cause no visible changes in the cells. Hypertonic solutions contain more solutes than cells do, and the cells will begin to shrink. Hypotonic solutions contain fewer solutes than the cells do, so the cells will plump. Facilitated diffusion transports lipid insoluble and large substances. Glucose is transported via facilitated diffusion, and protein membrane channels or protein molecules that act as carriers are used. The passive process, filtration. Water and solutes are forced through a membrane fluid or hydrostatic pressure. A pressure gradient must exist that pushes solute-containing fluid from high pressure area to a lower pressure area, and filtration is critical for the kidneys to work properly. Active processes, ATP is used to move substances across a membrane. Active processes are used when substances are too large to travel through the membrane channel. The membrane may lack special protein carriers for the transport of certain substances. Substances cannot be lipid soluble, and they may have to go against a concentration gradient. Active transport and vesicular transport. Active transport, amino acids, some sugars, and ions are transported by protein carriers known as solute pumps. ATP energizes the solute pumps. In most cases, substances are moved against a concentration gradient. Example of this is a sodium potassium pump. These are necessary for nerve impulses. They're also necessary for your heart to send an electrical activity. Sodium is transported out of the cell and potassium is transported into the cell. Vesicular transport is where substances are moved across the membrane in bulk without actually crossing the plasma membrane. Types of vesicular transport are exocytosis and endocytosis. Exocytosis is the mechanism that cells use to actively secrete hormones, mucus, and other cell products, or eject certain cellular waste. Endocytosis includes ATP requiring processes that take up or engulf extracellular substances by enclosing them in a vesicle. If the engulfed substances are relatively large, such as bacteria or dead body cells, and the cells separate them from external environment by pseudopods, the endocytosis process is specifically called phagocytosis. Cells that eat by phagocytosis and drink by a form of endocytosis is pinocytosis. Mechanisms cells use to actively secrete hormones, mucus, and other products. Materials is carried in a membranous sac called the vesicles that migrates and combines with the plasma membrane. Contents of the vesicle are emptied to the outside. The The docking process, the docking proteins on the vesicles recognize plasma membrane proteins and bind with them. Membranes corkscrew and fuse together. In endocytosis, the extracellular substances are enclosed in a membranous vesicle, and vesicles detach from the plasma membrane and moves into the cell. Once in the cell, the vesicle typically fuses with a lysosome. Contents are digested by lysosomal enzymes, and in some cases, the vesicle is released by the endocytosis on the opposite side of the cell. Phagocytosis is cell eating. The cell engulfs the large particles such as bacteria or dead body or dead cell parts. Pinocytosis is cell drinking. The cell gulps droplets of extracellular fluid containing dissolved proteins or fats. Types of endocytosis. Receptor-mediated endocytosis is a method for taking up specific target molecules. Receptor proteins on the membrane surface bind only certain substances. Highly selective processes of taking in substances such as enzymes, some hormones, and cholesterol and iron. Cell life cycle is a series of changes in the experiences of the time it is formed until the time it divides. So the cell life has first interphase. Interphase is where the cell grows and carries out on metabolic processes. A longer phase of this cell cycle. Cell division is where it reproduces itself. When it's preparing for cell division, the DNA replication. Genetic material is duplicated and reads a cell for division into two cells, and it occurs towards the end of interphase. Recall that DNA is a complex molecule. It's composed of building blocks called nucleotides, each consisting of deoxyribose sugar, phosphate group, and nitrogen-containing base. Essentially, DNA is a double helix, a ladder-like molecule that is coiled into a spiral staircase. The upright parts of the DNA or backbone are alternating phosphate sugar salt units, and the rungs of the ladder are made of parts of nitrogen-containing bases. The process of DNA replication, DNA uncoils into two nucleotide chains, and each side serves as a template. Nucleotides are complementary. Adenine always bonds with thymine, guanine always bonds with cytosine. For example, bonds with nucleotides in the order ATGACG. ATCG, CG, ATCG. The event mitosis is the division of the nucleus that results in the formation of two daughter nuclei. Cytokinesis, division of the cytoplasm, begins with when mitosis is near completion. It results in the formation of two daughter cells. The events of mitosis, prophase, the chromatin coils into chromosomes. Identical strands called chromatins are held together by a centromere. Centrioles direct the assembly of myotonic spindle, and nuclear envelope and nuclei have broken down. We then go into metaphase. This is where chromosomes are aligned in the center of the cell on the metaphase plate and the center of the spindle midway between the centrioles. Straight line of chromosomes is now C. During anaphase, the centromere splits and the chromads move slowly apart towards the opposite ends of the cell. Anaphase is over when the chromosomes stop moving. Telophase, reverse of prophase, chromosomes uncoil to become chromatin. Spindles break down and disappear, and the nuclear envelope reforms around the chromatin. The nuclei appear in each of the daughter nuclei. In cytokinesis, the division of the cytoplasm, it begins during the late anaphase and completes during the telophase. A cleavage furrow, contractile ring of microfilaments, forms to pinch the cells into two parts, and now two daughter cells exist. In most cases, mitosis and cytokinesis occurs together. In some cases, the cytoplasm is not divided. Binucleate or multinucleate cells result. Common in the liver, this is common in the liver and the skeletal muscles. Protein synthesis. DNA serves as a blueprint for making proteins. Gene DNA segment that carries out a blueprint for building one protein or polypeptide chain. Proteins have many functions. They can be fibrous or globule. Fibrous proteins are the building materials for cells, and so structural, and globular is the functional proteins that act as enzymes and catalysts. DNA information is coded into a sequence of bases. A sequence of 3 bases codes for an amino acid. For example, a DNA sequence, AAA specifies the amino acid phenylaline. Most ribosomes, the manufacturing sites of proteins, are located in the cytoplasm. DNA never leaves the nucleus in interphase cells. DNA requires a decoder and a messenger to carry instructions to build proteins to ribosomes. Both the decoder and the messenger function are carried out by RNA. RNA and DNA are different. RNA is single-stranded. RNA contains ribose sugar instead of deoxyribose, and RNA contains uracil base instead of thiamine. RNA carries out the information that DNA sends out. There is 3 varieties of RNA: transfer, ribosomal, and messenger. Transfer is appropriate amino acids to the ribosome for building of the protein. Ribosomal helps form the ribosomes where the protein is built. And then messenger RNA carries the instructions for the building protein for the nucleus of the ribosome. Protein synthesis involves 2 major phases: transcription and translation. Transcription is the transfer of the information from DNA's base sequence to the complementary base sequence of messenger RNA. DNA is the template for transcription. Messenger RNA is the product. Each DNA triplet corresponds to a messenger RNA codon. If DNA sequence is AAT-CGT-CTG, then messenger RNA corresponding codes are UUA-CGCA-AGC. Translation: base sequence of nucleic acid is translated onto an amino acid sequence. Amino acids are the building blocks of proteins. It occurs in the cytoplasm and involves 3 major varieties of RNA. Tissues. Groups of cells with similar structure and function. 4 primary types of cells are epithelial, connective, muscle, and nervous. Epithelial tissue is found on the body coverings, body linings, and glandular tissues. Their function is protection, absorption, filtration, and secretion. Hallmarks of epithelial tissues are it covers and lines the body. It often forms sheets with one free surface, the apical surface, and the anchored surface, the basement membrane. Avascular, it has no blood supply and it regenerates easily if well nourished. Classification of the epithelia, it's simple one layer, stratified is more than one layer. Shape of cells, squamous, cuboidal, or columnar. Squamous is flattened, cuboidal is cube-shaped, and columnar is shaped like a column. Simple epithelia, the function in absorption, secretion, and filtration, it's very thin and it's not suited for protection. Simple squamous epithelium is a single layer of flat cells. It usually forms the membrane, lines air sacs of the lungs, forms the walls of capillaries, forms serous membranes that line and cover the organs of the ventral cavity. Its function is diffusion, filtration, and secretion in membranes. So that's the reason why the walls on our alveoli are so thin. They're simple squamous epithelium so that the gas exchange can occur. Simple cuboidal epithelium is a single layer of cube-like cells. It's found in common glands and their ducts, forms walls of kidney tubules, and covers the surface of ovaries. Its function in secretion and absorption, and its ciliated types propel mucus or reproductive cells. Simple columnar epithelium. These are single layers of tall cells. Goblet cells secrete mucus. Locations are the lining of the digestive tract from the stomach to the anus, and the mucous membranes and line body cavities opening to the exterior. This is because they have these goblet cells. The functions in secretion and absorption, ciliated types propel mucus or reproductive cells. So if we come over here to our assignment, we are on number 13. Goblet cells produce lubricating mucus and are often seen in simple columnar epithelium. So simple columnar. Pseudostratified columnar epithelium are all cells reset on a basement membrane, single layers, but some cells are shorter than others, giving a false pseudo impression of stratification. They are found in the respiratory tract, where it's ciliated and known as pseudostratified ciliated columnar epithelium. The functions is absorption or secretion. Thank you. Stratified epithelia consist of two or more cell layers, and their function is primarily protection. If we come over here again to our assignment number 14, which epithelium is built to withstand friction? This is the stratified squamous. On page 93, it states that the stratified squamous epithelium is found in sites that receive a good deal of abuse or friction, such as the surface of the skin, the mouth, and the esophagus. It's named for cells present at the free or the apical surface, which are squamous, functions as protective covering where friction is common, and it's found in the skin, mouth, and esophagus. Stratified cuboidal epithelium is two layers of cuboidal cells, and its function is protection, stratified columnar epithelium. The surface cells are columnar, and the cells underneath vary in size and shape. Its function is protection. Stratified, cuboidal, and columnar are rare in the human body and found mainly in ducts of large glands. Transitional epithelium is composed of modified stratified squamous epithelium. Shapes of the cells depend on the amount of stretching. Function in stretching and the ability to return to its normal shape. Its location is the lining of the urinary system. Glandular epithelium is one or more cells responsible for secreting a particular product. Secretions contain protein molecules in an aqueous fluid, and secretion is an active process. Two major glands develop from epithelial sheets, endocrine glands and the exocrine glands. Endocrine glands are ductless, and they secrete hormones directly into the blood vessels. Examples include thyroid, adrenals, and pituitary. Exocrine glands secrete empty through the ducts into the epithelial surface, and it includes sweat, oil glands, liver, and pancreas. Connective tissue is found everywhere in the body to connect the body parts. It includes the most abundant and widely distributed tissues. Its functions is to protect, support, protection, support, and binding. Characteristics of connective tissues, variations in blood supply. Some tissues are well vascularized, and some have a poor blood supply or are avascular. Extracellular matrix, non-living material that surrounds the living cell. Two main elements of the extracellular matrix are the ground substance, which is mostly water, along with adhesion proteins and polysaccharide molecules. Fibers, collagen, elastic, and reticular fibers. The types of connective tissue from most rigid to soft. Bone is obviously the most rigid, then cartilage, dense connective tissue, loose connective tissue, and then blood. Bone is composed of osteocytes, hard matrix of calcium salts, and large numbers of collagen fibers. Its function is to protect and support the body. Cartilage is less hard and more flexible than bone. It's found only in a few places in the body. Chondrocyte is cartilage cell. Chondro means cartilage. Cyte means cell. Is the major cell type. There's three different types: hyaline cartilage, fibrocartilage, and elastic cartilage. Hyaline cartilage is the most widespread type of cartilage. It's abundant in collagen fibers hidden by a glassy, rubbery matrix. You find this in the trachea. Attachments of the ribs to the breastbone covers the ends of the long bones. The entire fetal skeleton prior to birth, and the growth plates in the long bones. Elastic cartilage provides elasticity, supports the ear. Fibrocartilage is highly compressible. It's like the cushion-like discs between the vertebrae of the spinal column. Connective tissue, dense connective tissue, is the main matrix element in the collagen fiber. Fibroblasts are cells that make fibers. Locations are tendons, ligaments, and the dermis. Loose connective tissue is softer, and it has more cells and fewer fibers than other connective tissues. The types are areolar, adipose, and reticular. Areolar connective tissue is most widely distributed connective tissue. It's soft, it's pliable tissue like cobwebs. Its function is a universal packing tissue and glue to hold organs in place. There is a layer of areolar tissue called the lamina propria. It underlines all membranes. All fiber types form a loose network and can soak up excess fluid. Okay, so if we come over here to number 15, what kind of connective tissue acts as a sponge soaking up fluid when edema occurs? It is areolar connective. Adipose connective tissue, an areolar tissue in which adipose fat cells dominate. It insulates the body and protects some organs. It serves as a site for fuel storage. Subcutaneous tissue beneath the skin protects organs such as the kidneys. Fat deposits includes hips, breasts, and belly. Reticular connective tissue is a delicate network of interwoven fibers with reticular cells. It forms the stroma of organs. Its locations in the lymph nodes, the spleen, and the bone marrow. Blood cells surrounded by fluid matrix known as blood plasma. Soluble fibers are visible only during clotting functions as the transport vehicle for cardiovascular system carrying nutrients, waste, and respiratory gases. Okay, and we missed number 16. What type of connective tissue prevents muscles from pulling away from bones during contraction? So when you move, what prevents it from pulling away from the bones? On page 97, it states that dense connective tissue forms strong rope-like tendons and ligaments. Tendons attach to the skeletal muscles to the bones, and ligaments attach the bones to the joints. Okay, muscle tissue, and then we're done. Function is to contract and shorten to produce movement. There's 3 types of muscle tissue: skeletal, cardiac, and smooth. Skeletal muscle tissue is packed by connective tissue sheets into skeletal muscles, which are attached to the skeleton and pull on bones or skin. Voluntary or controlled produces gross body movements or facial expressions. Characteristics of skeletal muscles, striations or stripes, multinucleate, more than one nucleus, and their long cylindrical shape. Cardiac muscle is involuntary and it's found only in the heart. It pumps through the blood vessels, and its characteristics of cardiac muscle cells: they are striated, one nucleus, short branching cells. Intercalcated discs contain gap junctions to connect the cells together. So if we come over here to number 17, which of the following terms describe muscle? It is striated, like skeletal muscle. Cardiac muscle has striations, but cardiac cells have only single nucleus and are relatively short. Intercalcated discs. On page 99, it says the cells fit tightly together at junction called intercalated discs. These discs contain gap junctions that allow ions to pass freely from the cells. They only have one nucleus, so they are not multinucleate. They are involuntary. Cardiac muscle is under involuntary control, which means we cannot concisely control the activity of the heart. They are also branching. Cardiac cells have a single nucleus and are relatively short, branching cells that fit together tightly. So, striated, intercalcated, involuntary, and branching. But there is only one nucleus. Smooth muscle tissue is involuntary controlled. It's found in walls of the hollow organs such as the stomach, the uterus, The blood vessel. Peristalsis is a wave-like activity. It is a typical activity. Characteristics of smooth muscle cells, no visible striations, one nucleus per cell, and one spindle-shaped cell. The function is to receive and nervous tissue. The function is to receive and conduct electrochemical impulses to and from the body parts, irritability and conductivity. Composed of neurons and nerve support cells called neuralgia insulate, protect, and support the neurons. Tissue repair occurs in two ways. Regeneration is the replacement of destroyed tissue by the same kind of cells. Fibrosis is repair by dense fibrous connective tissue, which is scar tissue. Whether regeneration or fibrosis occurs, it depends on the type of tissue damaged and the severity of the injury. Clean cuts heal more successfully than ragged tears of the tissue. Events on tissue repair. Inflammation sets the stage. Capillaries become permeable. Clotting proteins migrate to the area from the bloodstream, and a clot walls off the area where injured. Granulation tissue forms, growth of new capillaries, phagocytes dispose blood clots, and fibrocytes rebuild collagen fibers. Regeneration of fibers affect permanent repair. Scab detaches. Whether the scar is visible or invisible depends on the severity of the wound. Epithelial tissues and fibrous connective tissues and bones regenerate very easily. Skeletal muscles regenerate poorly. Where they're replaced with scar tissue is cardiac muscle and nervous tissue. Developmental aspects of cells and tissue. Growth through cell division continues through puberty. Cell population exposed to friction, such as epithelium, replace lost cells throughout life. Connective tissue remains mitotic and forms repair or scar tissue. With some exceptions, muscle tissue becomes amniotic by the end of puberty. Nervous tissue becomes amniotic shortly after birth. Injury can severely handicap amniotic tissues. The cause of aging is unknown, but chemical and physical insults, as well as genetic programming, have been proposed as possible causes. Neoplasms, both in benign and cancerous, represents abnormal cell masses, which normal control on cell division are not working. Hyperplasia is an increase inside of a tissue or organ and may occur when a tissue is strongly stimulated or irritated. And atrophy is the decrease in the size of a tissue or organ and occurs when the organ is no longer stimulated. If we come over here to our last question, cancer is the same as all tumors, all neoplasms, all malignant neoplasms, benign tumors, or AIDS. On page 0104, it discusses that an abnormal cell mass is a neoplasm. Some are cancerous, some are not. A cancerous neoplasm is called a malignant neoplasm. Benign means not cancerous. Not all tumors are neoplasms, and AIDS is not cancer. All right, we are done here. I hope that you guys have a fantastic week. If you have questions, call me. Thank you. Or email me. Thank you.